At the end of Calc 1, there are two techniques that can be used for integration. One of them is recognizing the antiderivative readily and using the fundamental theorem of calculus. The second technique is U-substitution. U-substitution is used when you have something that comes from the derivative using a chain rule. And in order to anti-differentiate, we're going to unwind that chain rule by using what's called U-substitution. So your integral should look something like this, where you have a composite function, right? That's where we use the chain rule, times the derivative of that inside function right there. So when you have something you want to integrate that looks like that, you use U-substitution. And what you're going to do is you're going to let U be something by making an appropriate substitution. That appropriate substitution is letting U be the inside function of that composite that you identified. So we let U be g of x, that's our inside function, and then we need to account for the fact that our original integral is with respect to x. So we're going to take the differentials of both sides of that expression, U equals g of x. When we do so, we obtain du equals g prime of x times dx. Notice now, with both of these substitutions, I can see that u will go right there for g of x, and du is exactly that g prime of x dx. So we get a new integral that's a du integral. And that integral is precisely the integral of g of a to g of b of f of u du. So again, here was my f of u with the substitution, and here is my du. Now notice, more than just the expression after the integral sign changed. Also, my limits of integration changed. Here I have a g of a, and here I have a g of b. This is an important distinction. My original integral was being integrated with the variable x, and now my new integral is being integrated with the variable u. So my limits of integration need to reflect the variable that I'm using. So I go to my original, and I see that my lower limit's an a, and so I say when x is a, well, what is u? Well, we're going to use the fact that u equals g of x. So if u equals g of x, when x is a, u is g of a. And that's exactly where that lower limit right there came from. Now, my original upper limit was a b, and now I need, again, to account for the fact that my new integral is with respect to u. So I look to see what happens when x is b. And when x is b, u is going to be g of b. And that's precisely where my new upper limit comes from. So all of this, again, then says, when we want to make a replacement for the integral, and we start with something that was the derivative that came from a chain rule, I'm going to be able to integrate by using U-substitution. And it looks like this. So the integral from a to b of f of g of x times g prime of x dx with the appropriate u substitution, where I let u be the inside function, I get the new integral from g of a to g of b of f of u du.